So today you're going to be starting a new packet called Distributions, Centers, Shapes, and Spread. First we're going to talk about the mean and average for data distribution, and the standard deviation is a measure of spread or variability in a data distribution. So the standard deviation tells you how far you are from the mean. It'll be above the mean or below the mean. Okay? Below you have your normal distribution curve. Right here, this is your x bar, which is your mean. Okay? Here is your one standard deviation from the mean. Okay? And this point here is 2 standard deviations, 3 standard deviations. These are all above the mean. The 0.5, you're half a standard deviation from the mean. If we go to the left of the mean, you have -1 standard deviations from the mean. So you're 1 standard deviation below the mean, 2 standard deviations below the mean, and so forth. Okay? So if you add up these percents, okay, you will get approximately 68.2%. And if you add up here, you'll get approximately 95.4%. Okay? This is the data that falls within 1 standard deviation of the mean is 68.2%, and from here, from the -2 to the +2, you get 95.4%, which is approximately 2 standard deviations from the mean. So you need to write this down. So this says 95% confidence interval is 2 standard deviations from the mean, and sometimes we can see it mean plus or minus 2 standard deviations. And you need to know approximately 95% of the data falls in 2 standard deviations from the mean. So we're going to look at page 2, which talks about the different distribution shapes. We've got symmetric or skewed. Okay. The spread of the distribution, talking about the variability. So the first two we're going to look at is the top two right here that talk about the symmetrical shape. Okay. The left and the right sides are roughly mirror images. And if you look at this one here, you got your middle, then you've got this side has 1 and 1, and then this side and they're about the same size. This one looks a little different, this second one, but it's pretty symmetric on both sides. Okay? They have a mound shape, a distribution that is approximately symmetric with one single peak. Okay? Then on the bottom we talk about skewed shape. One side has noticeably longer tails, skewed left or skewed right. This one here with the skewed right, this one has a longer tail on the right. And this one here, it's skewed left, so it has a longer tail on the left. So now we're going to look at page 3. Okay? And page 3 says, consider the following histograms, histogram 1, 2, histogram 3, and 4. Descriptions of the 4 distributions are given. Match the description of the distribution with the appropriate histogram. Okay? So finding the difference between the mound shape and the skewed left or skewed right is going to be easier to see. The part that's going to be tricky is determining which standard deviation. So if we look below, we can narrow down the skewed right to these two right here. Okay? And we can narrow down the approximately symmetric, because you have the ones that look like peaking on the top and then going out on both sides, to right here. So these I would say would be B or C, and this side over here would be A or D. But now we need to sit here and determine, well, which one would have a standard deviation of 10 and which one would have a standard deviation of 40. Okay? So let's talk about the standard deviation of 40. So what you need to know is the higher the standard, and you're writing this down, deviation, the more spread out the scores will be. This also means more variability. Oops. Okay, so if you look down at histogram 2 and 4, you want to look at, is the data more squished together or is it more spread out? Okay? And if you look at it for number 4, this one right here, down on the bottom, the scores are more spread out. Right? It goes to about 350, whereas histogram 2 only goes to 140. So this one here would be better choice for your standard deviation to be 40. So where it says skewed right standard deviation 40, I would say that is histogram D. So you put that up in the box above. Okay? Therefore, histogram number 2 has to be letter A. Okay? Now let's look between histogram 1 and histogram 3 and decide which one you think would have a standard deviation of 10 and which one would have a standard deviation of 40. So take a few minutes, look at it. So between histograms 1 and 3, the data in histogram 3, the bottom numbers are more spread out, therefore you would have a bigger standard deviation. So histogram 3 should go with choice C. Oops. Choice C, therefore number 1 should go with letter B. Okay. So now take a few minutes and look at question number 2 on page 4 and try to fill out the distributions just like you did on this page. So now we're going to turn to page 7. We'll cover pages 5 and 6 on Tuesday when I get back. You should have completed question number 2 on page 4, so now we are turning to page 7, and we're going to talk about normal distribution and z-scores. Okay? So take a few minutes and look at the first question, letter number 1, and write down what type of distributions letter A, B, and C are. So letter A, I would say this is a normal distribution. It's symmetric. Okay. Letter B, this would be a distribution that's skewed right. And this one here has your mound shape, so it's also a normal distribution, symmetrical. Okay. So before we talked about the distribution curve and we talked about 1 standard deviation and 2 standard deviations from the mean, and we talked about exact percents based on the bell curve. Well, now we're going to talk about z-scores, and z-scores is the measure of the number of standard deviations away from the mean. But here's the key, this time it could be decimal points. It could be like 2.234 or 0.57, so it's not an exact one every time. Okay? And the first bullet says a positive z-score corresponds to a value that is above the mean, a negative z-score corresponds to the value below the mean. And how do we find out the z-score? Well, that's easy enough. You're going to take the value they give you, you're going to minus it from the mean, and you're going to divide it by the standard deviation. So let's look at number 2 on the bottom here. Number 2 says the prices of printers and scores have a mean of $240 and a standard deviation of $50. The printer that you eventually choose costs $340. What is a z-score for the printer what is a z-score for the price of the printer? So this right here, your 340, that is your value. Right? This here stands for your mean, and this here stands for your standard deviation, which I'm going to label ST. So to find the standard deviation, you're going to write Z equals, and you're going to put 340 minus 240 divided by 50. So on top we get 100, and on the bottom we get 50. We divide that out and we get 2. So our z-score is 2. And it says how many standard deviations above the mean is your printer in part B. So that means that it's 2 standard deviations above the mean. Okay. So now we're going to turn to page 8. Now you guys turn to page 8 and try number 3 on your own. After you finish this page, make sure you go back and you finish the other example I asked you to do earlier in the packet. Once you finish both of these, you could start working on your homework, which is Castle Learning. This is due Tuesday night by 11:59 p.m. See you tomorrow.